Hello everyone, let's solve the problem number 57. Insert interval. So what the question states here, we are given a sorted array of non-overlapping intervals. So here you can clearly see, right? So here we have been given a sorted array of non-overlapping intervals. We have to insert a new interval into the array while keeping the array sorted and merging any overlapping intervals. So we have to merge the if any overlapping intervals found, then we have to merge them. That's what they have given here. Insert a new interval into the array while keeping the array sorted. So we have to keep the array sorted itself, and if any overlapping intervals is found, then we have to merge them. So that's what they have asked in the question. You can clearly see here we have been given the intervals and new interval, right? So output has to be here in this case 1, 5 and 6, 9. So let's come to first example here. We have 1, 3 and 6, 9 here, right? So new interval we have been given here 2, 5. So whenever we try to merge here, so this is between this one, right? 1, 3 and 2 comes between 1, 3. So this is an overlapping interval and we have to merge this one, right? So 1, 3 and 2, 5. When we merge this one, we will at the right this one, we will compare whether 5 is greater than 3 or not. So this one, which is the greater number, that one we will basically here return here. In this case, we have 1 and 2. Basically, we will keep the 1 itself, right? So we'll keep the smaller one. And here in this case, for the right number, 3 and 5 we have, right? So 3 and 5, the bigger number we will return here. In this case, we have 1. This becomes 1, 5 basically. 6, 9 remains as it is, right? 6, 9 remains as it is. So the output we have to get here as 1, 5 and 6, 9. So intervals, let's come to the second example. We have 1, 2, 3, 5, 6, 7, 8, 10 and 12, 16 here. In this case, we have 1, 2 and new interval we have been given 4, 8. So 4 comes between 3, 5, 4, this one 4, 8 also we have been given, right? Here in this case, this comes between this one 6, 7 and 8, 10 as well, right? 8 we have this one 8 here, right? In between 3 to 10 it comes, right? 4, 8. Here it comes between this one 3, 5, 6, 7 and 8, 10 basically. Here in this case, we will return the smaller one here in this case for the left one. So here this will be 3, among this one, the right numbers, the right side we are considering 5, 7 and 10. We will return the largest one. So here in this case it will be 10, 3, 10, right? So when we merge this one, so output we need to get here as 1, 2 remains same, the first one basically, right? So here and 12, 16 also remains the same here in this case, right? So this will be 1, 2, 3, 10 and 12, 16. The output that we need to get here. The same thing they have written here, right? So because the new interval 4, 8 overlaps with 3, 5, 6, 7 and 8, 10, it becomes basically 3, 10. So we know this one, how we got 3, 10, right? So now I hope the question is completely clear. I hope whatever we need to do is completely clear as well. First, let's discuss the approach, then followed by the edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. Initially, let's discuss the. So we will be considering, or we'll be going with the linear scan approach. So just remember this, we'll be going with the linear scan approach. I have considered the same first example that they have given in the question, right? So here intervals is 1, 3, 6, 9. In this case, new interval we have to add 2, 5, and this basically overlaps, right? Between 1, 3. So this is basically between 1, 3. So what will happen here? First, the least number among 1 and 2 we will consider this one. This one will consider the least one, and within right the numbers that is present at the right will consider the max one. So this will be basically 5 when we merge. So this will be 1, 5 and 6, 9 remains same. So the output will be 1, 5 and 6, 9. So we have discussed this one earlier itself, right? So let's move on with the step-by-step explanation. Same example I am considering here, the first one. Intervals 1, 3, 6, 9, new interval 2, 5. So initial state will be the same, 1, 3, 6, 9. This will be the initial state basically. New interval is 2, 5. Let's move on with the next step here. Compare each interval. So we'll be comparing each interval here. So interval of 0 is 1, 3, the first one I'm speaking of, 1, 3 and 6, 9, right? So this overlaps with the new interval 2, 5. So we will be merging 1, 5 here in this case. So we have already discussed this one. We are just discussing this one step by step. So we have to implement the same thing or we have to articulate the same thing in the form of code, right? So this will be helpful basically. So here interval of 1 is 6,9, which has basically which has no overlap. So we will keep this one as it is, right? So that's why I have written here keep as is. So this is fine. So next the final output will be, the final merged intervals will be 1, 5 and 6,9, right? So the output that we got here is 1, 5 and 6,9, which is equivalent to the output that they have given for the example 1 in the question. So the output, so the approach works absolutely correct in this case. Now as we are completely familiar with the approach, let's discuss the edge cases one by one. So here in this case, the first edge case is for the empty intervals, right? So here we have nothing. So we are considering, we are going with the empty intervals as we are going with the empty intervals here. So new interval is 2, 5. When we merge here, we'll get 2, 5, right? So here in this case, we got 2, 5. So we are just returning the new interval since no intervals to merge here. In this case, let's move on with the second edge case here. New interval before all. So here we have 5, 7 and 1, 3. So we have the new interval before all, right? So we will be putting this one at the first 1, 3, 5, 7 will be the answer, right? In this case, no overlap is found. So we will add the new interval before. Let's move on with the third edge case here. So this is for the new interval after all. So here in this case, we have the new interval 1, 2 and 3, 4 basically, right? We have the new interval 1, 2 and 3, 4 here. So this basically merge with this one, right? So here what we will do, so sorry, this one we doesn't have 1, 2 here in this case. So we have only 3, 4 as new interval basically. I have written wrong here. Don't consider this one. So we just have 3, 4 here. So output will be 1, 2 and 3, 4. So we have the new interval 3, 4 and interval as 1, 2. So this doesn't merge with this one, right? 1, 2, 3 and 4 we have. This doesn't merge within this interval, right? So we will return the output as this one, 1, 2 and 3, 4. Let's go with the fourth edge case here, overlaps with all. So intervals we have here as 1, 2 and 3, 5 and the new interval we have here as 0, 6 basically. This merges with both actually in this case, right? So among this one, 1, 3 and 0, the least number is 0, and among 2, 5 and 6, the least the greater number is 6 here in this case. So we will return the 0, 6. This merges, this is between 0, 6 is between the basically 0, 6 merges with 1, 2 and 3, 5 both, right? So accordingly with the number. So in this case, so we will check among the three the left least, right? So this one and this one, least is 0. So left we have got the left number 0. Yeah, the right coordinate among this one and this one, which is the highest, 6 here. So we will return the largest number basically, 6 in this case, 0, 6 we have returned. So this was the fourth this one edge case, and let's move on with the fifth edge case here, touching intervals. So here in this case, 1, 2, 3 and 4 we have, right? So 1, 2, 3 and 4 we have. New interval we have been given 2, 3. So this basically again, when I said touching intervals, this merges with 1, 2 and 3, 4 as well, right? So in this case, the smallest among this one, 1, 2 and 3, 1, 3 and 2 basically is 1. So 1 we will give it the left side, left coordinate. So the right one will be, we have to go with the larger one, right? So 2, 4 and 3. So we will go with the largest number, 4 in this case. So 1, 4 will be the output here in this case. So these are the 4 edge cases that we need to consider here. The first one is for the empty intervals. The second one is for the new interval before all. The third one is for the new interval after all. So here in this case, second one, this one is for new interval before all. The third one is new interval after all. The fourth one is for overlaps with all, and the fifth one is for touching intervals. I hope all the edge cases are clear. Now, as we are completely familiar with the edge cases as well as the approach, we are good to write the code. Let's start writing the code. So the first step here is, let's initialize the result list as well as the variable. So I'll just go with the list here. In this case, let me give int, which is of type integer. So I'll just go with here the result name, I mean the variable name result here. We are making use of the array list, right? So I've given list initially. So I'll just create the array list. So I'll just give here array list. So this is fine. So we are just storing the merged intervals. So the next step here is we are going with the iterator as well as the total intervals, right? So let's initialize that one. Iterator, let me initialize I to 0, and we'll be making use of the length of the intervals in the code. So let me assign that one to the variable, some variable, right? So I'll just go with I'll just assign this one to the n intervals dot length. This is fine. So let's go with the next step here. The next step here, we have to add all the intervals before the new interval. So when there is no overlap. So this is for the condition when there is no overlap. So then we have to add all the intervals before the new interval, right? So let's try to articulate the same thing in the form of code. I'll just write the simple while loop here. I less than n, and here intervals of I, this will be 1. This is fine. If it is less than new interval, right? So I'll just write here new interval of 0. This is fine. So then what we need to do here, we have to we are safe to add as it is, right? So here in this case, I'll just make use of the add property, result.add. So this will be intervals. Within the intervals, let's increment the iterator here, I++. So this is fine. So let's come out of this while loop. So the next step is we have to merge the overlapping intervals with new interval, right? Here in this case, from line number 5, this one from line number 6 to 8, what we did, we wrote the code to add all the intervals before the new interval, means there is no overlap here. So in this case, when overlap is found, then we have to merge those intervals, right? So we are merging the overlapping intervals with new interval. This is the next case basically. So let me write one more while loop here. While I less, we are going with a linear scan, right? So here in this case, while I less than n, and intervals here, intervals of I 0, which is less than or equal to new interval of 1 here in this case. This is fine. So within the while condition, we have to update the start and end, right? So we have to merge the intervals. The condition is, so for the left one, we have to go with a small this one small digit, and for the right coordinate, we have to go with a large digit. So I'll just go with here new interval. So let me copy this one. We will be making use of this one everywhere. New interval. So this has to be interval, right? So just give me a second here. New interval of 0. This will be math.min of, let me paste the new interval of 0 here. This one, comma, intervals of I0. I0. We are considering the minimum for the left coordinate, right? So this is fine. We are just updating the start here. We have to update the end as well. So I'll just go with the new interval of 1 here in this case. So this will be math.max of this one again. New interval of 1. In this case, we are updating the end, right? Don't get confused here. So intervals of I1. End means the right coordinate. We have to take the max, right? For that. So that one I'm speaking of. Let's this one increment the iterator here, I++. So this is fine. We have to move to the next one, right? So we are incrementing the iterator here. So this is fine. These two conditions, I hope this is clear. We have discussed this one several times. So this is for merging the overlapping intervals, and this is when no overlap is found, right? So next step here is we have to add the merged new interval. We have to add the merged new interval after merging. So I'll be making use of the add property to the result. So I'll just give here result.add of new interval, right? So this is fine. So let's move on with the next step here. We have to add the remaining intervals of the new interval, means when there is no overlap. So I'll just go with here while I less than n. Here what I'll do, the result dot add here of intervals. This one, let me increment the iterator here. This one I'll just keep I++. This is fine. We are just adding as it is. So we are just adding the remaining intervals of the new intervals. Means when there is no overlap again. So this one. So this is fine. So the final step here is we have to convert the list to the 2D array, and then we will return, right? So I'll just go with here return result. We are converting this one to the 2D array, right? I'll just give here to array. So this is of the type int, so I'll just go with new int. Within the array, I'll just give result dot size. We are just converting the list. So we are making use of the array list, which basically we are converting that list to the 2D array, and then we are returning, right? So this is result dot size. So this is fine. This 2D array again, I have to mention array here, right? So this is fine. So this is it for the code. Let me format this one once and let me hit the run button. So here we have the I has to be small here. Where is this new int? So this is fine. Let me hit the run button again. So here you can clearly see the sample test cases are getting passed, right? So let me hit the submit button. I hope this works for all the test cases. Let's see. So yeah, here you can clearly see all the test cases are getting passed. Means the code works absolutely correct on this case, right? So let's quickly discuss the complexities for the code that we have written. So the approach that we went with here is linear scan. We know this one, right? So the approach that we went with here is linear scan. So what would be the overall time complexity here? Overall time complexity would be big of n. Why it is big of n? Because here we are visiting the each interval exactly once. We are visiting the each interval exactly once. So in the worst case, it would be big of n, the time complexity. We have to check for all the this one. We have to iterate through all the elements once, right? So here in this case, the time complexity would be big of n, right? So what would be the space complexity here? The space complexity would be big of n as well. Why it is big of n? Because here we are making use of the result list. Basically, finally, we are converting that one to the array. But initially, we are making use of the array list, where it is this one, line number 3 I am speaking of, right? So we are making use of the array list. So the result list stores up to n plus 1 intervals in worst case, right? In worst case, we are storing n plus 1 intervals in the result list. So the output would be big of n. Means the space complexity here is big of n. The time complexity is big of n, and the space complexity is big of n for the code that we have written, right? So I hope the complexities are completely clear, and I hope whatever the code that we have written is completely clear as well. For now, this is it. Thanks for watching, guys.